This is for Year 12 methods. It's set number 2, question number 2 out of 3.7. Find all the solutions to 1 minus cos of x equals 2 sine squared of x over the domain x going from 0 to 2 pi. Now, I've got a little problem in this question, and the question is that I've got a cos of x and I've got sine of x. And I've got a 1, so I can't do a division and get tan because I've actually got a sine squared. It'd be really good if they were both coses or they were both sines. There's no way I can turn cos x into sine of x, but there is a way that I can turn sine squared of x into cos squared of x, because I know that sine squared plus cos squared equals 1. Therefore, sine squared of x equals 1 minus cos squared of x. And if I did this replacement for that, I would then have an equation just in terms of cos. So I'm going to do that. 1 minus cos of x will equal 2 lots of sine squared is equal to 1 minus cos squared. So 1 minus cos of x equals 2 minus 2 cos squared of x. And if I move everything to the left-hand side, the negative 2 cos squared will become 2 cos squared of x minus cos of x, and I'll have 1 minus 2 is minus 1 equals 0. Now that looks like a trinomial. Let's say I replace cos of x with the letter a. So I've got 2a squared minus a minus 1 equals 0, of which I can crisscross 2a and a, 1 and 1. One of those ones have to be a negative. I want a minus 2a, so I want the one opposite the 2a, so that when that gets multiplied I get minus 2a, and I get a, and add them together I get minus a, which is what I want in the middle. So I know that I have 2a plus 1 and a minus 1. However, a is cos of x, so I've got 2 cos of x plus 1, and I've got cos of x minus 1 equals 0. Now, looking at those two solutions, either cos of x minus 1 equals 0, which means cos of x equals 1. Now, cos of x equals 1, cos is the x coordinate, whereas the x coordinate equal to 1 is equal to 1 there at 0 and 2 pi. And since 0 and 2 pi are inclusive, two answers for x that satisfy this are 0 and 2 pi. So there are two answers so far. If 2 cos of x plus 1 equals 0, that means cos of x equals negative a half. Where is cos negative? All stations to Coburg. Cos will be negative there and there at pi minus theta and pi plus theta, and theta in this particular case is pi on 3. Therefore x is going to equal, I've got cos of x equals negative a half, and theta is pi on 3. Therefore x is going to equal pi minus pi on 3, or pi plus pi on 3. X equals 2 pi on 3, or 4 pi on 3. Now that gives me 2 more answers, and if I look at my 2 answers that I found for the other factor, 0, 2 pi on 3 and 4 pi on 3 are the 4 solutions that satisfies that question.